This is the sound of the Falcon Heavy, lifting off from Pad 39A at the Kennedy Space Center. With 27 Merlin engines firing to produce 5.5 million pounds of thrust, it's fair to say it's pretty loud. For rockets with this much power, the sound energy produced by the engines can actually be very damaging to the rocket itself, as well as the surrounding buildings. In this video, we're going to look at the method that NASA uses to reduce some of the sound damage. We're also going to look at the unique way that the Russians deal with this problem. When a rocket lifts off from the launch pad, the engine exhausts fire hot gas into the flame trench. Along with the incredible heat energy coming from the engines, there is also a lot of sound energy. According to NASA, the Saturn V produced a sound level of around 220 decibels during liftoff. If you were in close proximity to the engines, it wouldn't just rupture your eardrums, it would kill you. During the launch of the first space shuttle flight STS-1, the sound energy produced by the engines was powerful enough to damage some of the protective thermal tiles on the shuttle's hull. Although NASA used sound suppression systems in the past, the risk of damaging the rocket or putting the crew in danger was higher for the shuttle due to its unique shape and sensitive heat shield. To avoid damaging the vehicle or putting the crew in danger, NASA solved this problem by implementing a more effective sound suppression system. This consists of a large water tower at the launch site, which dumps over 1 million pounds of water onto the launch pad in just 40 seconds. As the sound waves meet the water, they are absorbed by bubbles of air, which contract and heat up, turning the sound energy into heat energy. Along with this enormous spray of water, NASA also used water bags at the base of the SRBs to further dampen the shock waves. These were large nylon bags, each about 1 foot wide and 1 foot deep, filled with water and stretched across the SRB flame holes. Together, these two systems were able to reduce the sound level of the space shuttle from 195 decibels to a more respectable 142, the equivalent of a jet taking off. Although it can be difficult to see the water deluge system in action, it's during a sound suppression test that we really get a sense of just how much water is used. Dumping this much water onto the launch pad not only protects the rockets and nearby buildings from intense shock waves, it also stops any fires that might be caused by the rocket's exhaust. To this day, NASA still uses a very similar water deluge system at all of their main launch sites. The Russians, on the other hand, have a different approach. Since a lot of the Russian Soyuz rockets launch from Baikonur in Kazakhstan, where the temperatures can be as low as -40 degrees in the winter, a water deluge system would freeze up instantly, making it completely useless. Their solution is to simply suspend the rocket over a much larger flame trench. This means that there is very little in the way for the shock waves to damage or reflect back onto the rocket. So, although rocket science deals with some of the most complex engineering challenges, it's interesting to see that some problems can be solved with very simple solutions.